In this video, we want to use the cofunction identities to rewrite some examples to see what they look like in terms of their cofunctions. So let's start with this first one. If we have the sine of 37 degrees, based on the cofunction identities that we just talked about, this would be equal to the cosine of the complement. Now remember, angles are complementary if their sum is 90 degrees. So this means that the sine of 37 degrees is the cosine of 53 degrees. And we can easily check that by going to a calculator and see, oh yeah, the sine of 37 equals the cosine of 53. You know what? Let's do that. Let me just pull this guy up. So we'll move this guy over here. So this is what your TI-83 should look like, or even a TI-84. The button layout is still going to be very, very similar to this. So when we do this, one of the first things you want to make sure, don't worry about that. One of the first things you want to make sure of is that your mode is set to degrees. So this one is not, so I just need to go down and set this to degree and hit enter. Because if you have it set to radians, that's going to mean something completely different, and we're not ready for that yet. I'm going to press second mode to quit. So now if I type, what's going on here? What in the world is going on here? All right, so let's check with the graphing calculator so that we can verify that we have the same values. So if I do sine of 37, we get this decimal. The decimal is not really all that important, but we do want to check to make sure that that's the same thing as the cosine of 53. And you see that it is. So this is great. We can see how these cofunctions work together. All right, back to our examples. So example number 2 has the cosecant of 48 degrees. Well, this should be equal to the secant of the complement, so 90 degrees minus 48 degrees, which is going to equal the secant of 42 degrees. So cosecant of 48 degrees is equal to the secant of its complement. Number 3, we have the tangent of 16 degrees. So writing it using his cofunction, that would be cotangent. That's going to be 90 degrees minus 16 degrees. So the tangent of 16 degrees is the same as the cotangent of 74 degrees. And then our last example here is the cosine of 79 degrees. So rewriting this using his cofunction, which is sine, we're going to say 90 degrees minus 79 degrees, and we have the sine of 11 degrees. So there you have it. Now let's take this idea, let's take this information and use it to solve some equations. Okay. So let's look at example number 5. If I have the sine of 7x plus 2 is equal to the cosine of 2x plus 16. Remember what we've said before about these cofunction identities? If sine is equal to cosine, that means that these guys must be complementary. And what does it mean to be complementary? It means that if you add them together, you get 90 degrees. So that's the equation that we set up. We simply say that 7x plus 2 plus the other representation for the angle measured, 2x plus 16, the sum here is equal to 90. And from this point on, it's just a nice, simple equation for us to solve. 9x plus 18 is equal to 90. Subtract 18 in an effort to get the variable by itself. So 9x is equal to 72. Divide both sides by 9, and x equals 8. Now, I do want you to know that if this said sine equals sine, well, the way that sine would equal sine is if the expressions on the inside are the same. But here, when could sine equal cosine? Well, that's when the angle measures inside are complementary, meaning they add up to give me 90. All right, so let's do another one. Okay. So if I have the cosecant of 3 theta minus 20 is equal to the secant of 3 theta plus 8. Again, in order for cosecant and secant to be the same, then the angle measures inside must be complementary. So that means we get to set up our equation. 3 theta minus 20 plus the other measure, 3 theta plus 8, is supposed to equal 90. And then it becomes the same kind of question that we had above, right? So we're going to combine like terms. 6 theta minus 12 is equal to 90. Move the constant to the other side. Then we have 6 theta is equal to 102. Divide both sides by 6. And theta is equal to, let's see, 6 goes into 102, goes in once. 42, so 17 times. There we go. So theta is equal to 17. All right. So the next videos that we're going to be seeing are going to deal with some very, very special triangles, so you don't want to miss it.